In the middle of World War II, German engineers were famous for building machines so complex that even their own mechanics struggled to repair them. So when a captured American Jeep rolled into a German workshop, most men laughed before even opening the hood. But hours later, the laughter stopped. Something inside that Jeep made hardened engineers stare in silence, convinced a mistake had been made, because by every rule they believed in, this design should not have worked. No blueprints explained it, no equations justified it, and yet it worked flawlessly. By the end of this story, you will discover what that impossible design was and why Germany never truly understood it until it was too late.
On July 10, 1943, as Allied forces stormed the beaches of Sicily under relentless fire, chaos unfolded across the island's interior. Tanks burned, supply columns scattered, and small units became isolated from their commands. Amid this confusion, a lightly damaged American Jeep, its paint scarred by shrapnel and its windshield shattered, was abandoned near a dirt road outside the town of Gela. Its driver had fled under mortar fire, believing the vehicle would be destroyed within minutes. Instead, German troops reached it first. To most German soldiers, the Jeep was unimpressive. It looked crude. The metal panels were flat and thin. The suspension appeared almost primitive. Compared to Germany's meticulously engineered vehicles, it seemed like something built in a hurry by amateurs. The soldiers searched it for maps, radios, or intelligence, then prepared to destroy it. But one officer stopped them. He noticed something unusual. The Jeep had crossed terrain that heavier German vehicles had failed to navigate that morning. Mud that swallowed half-tracks had barely slowed it. Curiosity replaced contempt. The Jeep was sent to a nearby maintenance depot used by German engineers tasked with examining captured Allied equipment. These men were not ordinary mechanics. Many had studied mechanical engineering before the war, trained in a culture that worshipped precision, complexity, and theoretical perfection. German engineering philosophy prized machines that were mathematically elegant, tightly toleranced, and optimized for peak performance, even if that meant they required expert hands to maintain. When the Jeep arrived at the depot, it became an object of mild amusement. Engineers gathered around it, smoking cigarettes, making jokes about American industrial shortcuts. They expected to confirm what they already believed, that the Jeep worked only because Americans threw massive resources at production and didn't care about refinement. The plan was simple: open it, document its flaws, and move on.
They began with the suspension. Leaf springs, simple and rugged, were mounted with generous clearances. There was no attempt at sophistication, no elaborate geometry, no fine adjustments. One engineer noted that such looseness would normally cause instability or rapid wear, and yet the Jeep's suspension showed no serious damage despite rough use. That was strange, but not alarming. Next came the drivetrain. The transfer case immediately drew attention. It was compact, straightforward, and almost shockingly accessible. Bolts were placed where hands could easily reach them. Components were designed to be removed without special tools. One engineer muttered that this was workshop logic, not engineering logic. But again, the parts showed minimal stress fractures, even after off-road abuse. Then they turned to the frame. German vehicles often used complex reinforced frames, optimized for strength along specific load paths. The Jeep's frame, by contrast, looked almost naive. Straight rails, simple cross members, nothing fancy. An engineer measured the steel thickness and shook his head. According to German calculations, the frame should have twisted or cracked under combat conditions, yet it hadn't. As hours passed, irritation replaced confidence. Nothing they found matched their expectations. The Jeep wasn't advanced, but it wasn't failing either. It survived precisely because it ignored the rules German engineers lived by. The real moment of silence came when they examined how the Jeep handled stress and failure.
German vehicles were designed so that each component performed a precise role. If one part failed, the system often collapsed. Repairs required trained crews, proper tools, and factory-grade replacements. The Jeep was different. Its components were overbuilt in some areas and forgiving in others. Parts flexed instead of snapping. When something loosened, it didn't immediately destroy neighboring systems. One engineer noticed wear patterns that made no theoretical sense. Parts that should have worn evenly showed uneven scarring, evidence that the machine adapted dynamically to terrain and damage. It wasn't optimized for perfection, it was optimized for survival. They tested the Jeep next. The engineers drove it across uneven ground, deliberately abusing it. They overloaded it. They bounced it over rocks. They pushed it through mud. They expected something to fail, a cracked axle, a snapped joint, a twisted frame. Instead, the Jeep kept moving. It rattled, it protested, but it did not stop. This behavior unsettled them deeply. German engineering doctrine assumed that efficiency and precision produced superiority. The Jeep suggested the opposite. It suggested that simplicity, tolerance, and repairability mattered more in real war conditions than theoretical excellence. One engineer reportedly remarked that the Jeep was not designed to win awards, it was designed to be fixed by frightened soldiers in the dark, under fire. As word spread through the depot, more engineers came to see the captured vehicle. Some were defensive, insisting that such a design would never meet German standards. Others were quieter, taking notes. A debate emerged that went far beyond one Jeep. It was about philosophy, about whether Germany's obsession with perfection had become a weakness. But the most disturbing realization had not yet fully formed. Late that night, as measurements were rechecked and calculations rewritten, one engineer made a connection that chilled the room. The Jeep's most impossible feature wasn't any single part. It was how all the parts worked together despite being imperfect. The system was designed to accept mistakes, from manufacturing flaws to battlefield damage, and continue functioning. This was heresy in German engineering culture. Machines were supposed to resist failure through precision. The Jeep embraced failure and survived through forgiveness. And if this philosophy extended beyond the Jeep into American tanks, aircraft, factories, and logistics, then Germany wasn't just fighting an enemy with more resources, it was fighting an enemy that understood war differently. By the end of Part 1, the engineers had not laughed in hours. They stared at the Jeep as if it were a riddle they could not solve. They documented it, reported it, and moved on to other tasks. But something fundamental had shifted. They had seen proof that their beliefs might be wrong. They just didn't yet understand how devastating that realization would become. In the weeks that followed July 10, 1943, reports from the Sicilian depot quietly traveled upward through German command channels. Officially, they were dry technical summaries, measurements, tolerances, material notes. Unofficially, they carried something far more dangerous: doubt. The Jeep was not dismissed as a curiosity. It was classified, studied, and compared against German field vehicles, and every comparison produced the same uncomfortable result. On paper, German machines were superior. In the field, the American Jeep kept winning. German engineers tried to rationalize what they had seen. Some argued that American mass production simply allowed for waste. Others insisted that the Jeep's success depended on perfect conditions or careless Allied driving that masked long-term failures. But field reports contradicted those assumptions. Jeeps were appearing everywhere: North Africa, Italy, Eastern Europe, often still running after months of abuse that would have crippled German vehicles. Mechanics reported that captured Jeeps were easier to keep operational than their own trucks. This disturbed German logistics officers far more than frontline commanders realized. By 1943, Germany's war effort was straining under its own mechanical brilliance. Vehicles like the Panther tank or heavy half-tracks required specialized tools, trained crews, and precise spare parts. A broken seal or misaligned gear could immobilize a vehicle for weeks. On the Eastern Front especially, entire columns were abandoned, not because of enemy fire, but because they could not be repaired in time. The Jeep represented the opposite philosophy. It assumed parts would break. It assumed soldiers were exhausted, undertrained, and scared. It assumed tools would be missing, manuals unread, conditions hostile. And it worked anyway. German engineers attempted to identify a single flaw, something they could label as inferior. But the more they searched, the clearer it became that the Jeep's strength lay in how it handled imperfection. The tolerances were loose by design. Components flexed rather than shattered. If one part degraded, others compensated. Nothing relied on a single point of failure. This realization struck at the heart of German engineering doctrine.
Before the war, German industry had been shaped by the belief that technical excellence equaled battlefield dominance. Machines were expected to operate as designed, not adapt. Failure was treated as an anomaly, not an expectation. Training focused on ideal conditions. Maintenance assumed access to workshops. War, however, did not respect these assumptions. American designers, many of whom had backgrounds in civilian manufacturing rather than military theory, approached the problem differently. They asked what soldiers actually faced: mud, dust, poor fuel, minimal training, constant movement. Their answer was not elegance, but resilience. German engineers began testing captured Jeeps more aggressively. They removed parts and replaced them with inferior substitutes. They deliberately misaligned components. They reduced lubrication. Still, the vehicles ran. Poorly, noisily, inefficiently, but they ran. No German vehicle could tolerate such abuse without catastrophic failure. One engineer reportedly noted that the Jeep behaved less like a machine and more like a living organism. It adapted. It degraded gracefully instead of collapsing. This observation was never officially recorded. It was too philosophical, too unscientific, but it spread quietly among those who worked closest with the machines. By late summer 1943, German factories faced a painful contradiction. They could build brilliant machines, but not enough of them and not fast enough. American factories, meanwhile, were flooding Europe with vehicles that did not need perfection to function. Even when destroyed, they were easily replaced. Quantity amplified simplicity. Simplicity amplified endurance. The Jeep was a symbol of this imbalance. Attempts were made to copy certain features: simplified brackets, easier access panels, reduced part counts, but these changes clashed with existing German production systems, which were optimized for precision rather than speed. Retooling factories mid-war was nearly impossible. The German industrial machine was locked into its own complexity. Meanwhile, the psychological effect spread. German soldiers who encountered Jeeps in the field began to respect them. Some even preferred captured Jeeps to their assigned vehicles for scouting and transport. They knew they could drive them hard without worrying about immediate failure. This quiet admiration was dangerous. It undermined confidence in German superiority, something the regime relied upon heavily. By 1944, as Allied forces pushed deeper into Europe, the Jeep became omnipresent. It carried officers, hauled supplies, evacuated wounded soldiers, and navigated terrain that stalled armored vehicles. It did not dominate through firepower. It dominated through presence. It was everywhere, all the time. German command dismissed concerns publicly. Privately, they understood the implication. The war was no longer being decided by singular, brilliant machines, but by systems that could survive chaos. The Jeep was not just a vehicle, it was evidence of a broader American advantage, an industrial philosophy built for prolonged, unforgiving war.
Yet even then, many German engineers clung to the belief that complexity equaled progress. They believed that once conditions stabilized, superior design would prevail. They did not realize that the conditions would never stabilize again. The final irony was this: the Jeep's most impossible feature was never fully identified by German engineers because it wasn't mechanical at all. It was cultural. It was the willingness to accept imperfection as a strength rather than a flaw. And that lesson, once ignored, would echo far beyond one captured vehicle. It would echo in the collapse of supply lines, the abandonment of equipment, and the growing realization that Germany was losing not just battles, but the logic of the war itself.
By the beginning of 1944, the German war machine was unraveling under pressures it could no longer hide. Factories were bombed faster than they could be repaired. Rail lines were shattered. Fuel was scarce. Skilled labor was being pulled from workshops and sent to the front. Under these conditions, the difference between a machine that demanded perfection and one that tolerated chaos became fatal. German engineers understood this in fragments, but never fully connected the pieces. The captured Jeep had warned them. They simply did not listen. As Allied forces landed in Normandy on June 6, 1944, Jeeps came ashore by the thousands. They rolled off landing craft, splashed through surf, and were driving inland within minutes. Some stalled, some broke, many were repaired on the spot with whatever tools were available. A bent rod was hammered straight, a damaged line was bypassed, a failing part was swapped with another Jeep nearby. The system did not depend on individual excellence. It depended on interchangeability and forgiveness. German vehicles could not replicate this behavior. When a German truck failed on the Norman hedgerows, it often stayed there. A single missing part could immobilize it indefinitely. Recovery vehicles were scarce. Spare parts were incompatible between models. Maintenance crews were overwhelmed. Every breakdown became a small disaster. German engineers watching these developments felt a growing sense of inevitability. They could still build extraordinary machines, but they could no longer support them. Precision without sustainability became meaningless. The Jeep, once laughed at, now represented everything Germany lacked. Captured German reports from late 1944 reveal subtle changes in language. Engineers stopped criticizing the Jeep's crudeness and began using words like robust, field adaptable, and operationally resilient. These were not compliments in German engineering culture. They were admissions. Yet even then, the core misunderstanding remained.
German analysts continued searching for a single mechanical secret, a special alloy, a clever joint, an ingenious suspension trick. They never found one because it did not exist. The Jeep was not clever in the traditional sense. It was deliberately ordinary. The true design decision that made the Jeep impossible was made long before it ever reached the battlefield. American designers had chosen to design the Jeep not for engineers, but for soldiers, not for laboratories, but for mud, fear, exhaustion, and incompetence. They assumed mistakes would be made and built a machine that could survive them. They assumed parts would be abused and made them easy to replace. They assumed production would be rushed and allowed tolerances that still functioned. They assumed the vehicle would be used wrong and designed it anyway. This violated everything German engineering stood for. German machines were masterpieces when used correctly. The Jeep assumed nothing would ever be correct. As the Allies advanced into Germany in 1945, Jeeps appeared on roads that German vehicles had abandoned months earlier. They towed artillery, carried wounded civilians, and ferried officers between ruined towns. Some were barely recognizable, patched together from parts of multiple vehicles, dented, rusted, and scarred. they still ran. German engineers saw them again, now not as captured curiosities, but as symbols of defeat. Only then did the final realization fully form. The Jeep's impossible design was not a part or a layout or a material. It was the decision to sacrifice theoretical perfection in favor of systemic survival. It was a machine designed to lose pieces and keep going. It was built not to impress engineers, but to endure reality. Germany had built machines to dominate ideal wars. America had built machines to survive real ones. That difference could not be corrected late in the conflict. It was cultural, it was industrial, it was philosophical. By the time German engineers truly understood it, the factories were gone, the fuel was gone, and the war was already lost. After the war, Allied investigators examined German engineering failures and often concluded that Germany had been technologically advanced but strategically misaligned. The Jeep became a case study in military academies, not because it was revolutionary, but because it was honest. It acknowledged human weakness and built around it. German engineers, many of whom later worked in civilian industries, quietly adopted similar philosophies: simpler systems, redundancy, ease of repair, forgiveness. The lesson was learned, just too late to change the outcome of the war. And so the mystery that began in a dusty Sicilian workshop finally resolves here. The impossible design was never impossible at all. It was simply a machine built for war as it truly is: chaotic, brutal, and unforgiving, rather than war as engineers wished it to be. And that is why a vehicle once mocked by German mechanics helped decide the fate of a global conflict.